Hi, today we're going to look at Chapter 4, Lesson 2, which is talking about prime factorization and factors. Our definitions of factor are the numbers that can be multiplied together. So if you have a factor, what are the factors of 6? 1 times 6 and 2 times 3 are the multiplication problems that will give you an answer of 6. So the factors are 1, 2, 3, and 6. Prime factorization is a multiplication problem that is written with just prime numbers. So we cannot have numbers like 6 in a prime factorization because that's composite. You can only have prime numbers in a prime factorization problem. So for example, the prime factorization of 12 would be 2 times 2 times 3. Let's look at an example of listing factors. This is very easy to do. If we want to know what the factors of 12 are, that means all of the problems that can be multiplied together to give you an answer of 12. So we have 1 times 12, 2 times 6, 3 times 4. Now notice I'm at 3 and 4. I'm doing these in order starting with 1 times something, 2, 3. I'm back to 4, so therefore I know I'm finished. If I do it in this order and I come around in this direction, I know to stop when I get to that 4 because these numbers are just going to repeat themselves, like 4 times 3, 6 times 2, 12 times 1, which are the same problem, so we don't need to write them over again. So in order to list the factors, I have them in numerical order already, which you should write them in numerical order for your answer. We're just going to write 1, 2, 3, 4, 6, 12. 4, 6, 12. Those are our factors for 12. Let's look at another example. 21. So we're going to start with 1 times 21, 2 times something, no, we don't have a 2. 3, yes. 3 times 7, 4, no. 5, no. 6, no. I'm back to my 7, so I know I'm finished. I'm going to write mine in numerical order, so 1, 3, then 7, then 21. And those are my factors of 21. Let's look at prime factorization. Today we're going to look at the factor tree method, which most of you probably have already learned in elementary school. Tomorrow's lesson we're going to do prime factorization as well, but we're going to be looking at a ladder method, which is a little different, and most of you probably haven't learned the ladder method before. Let's look at the tree method. So for 48, remember prime factorization means you can only have prime numbers. We cannot have composite numbers in a prime factorization list. The key word is prime factorization, factors that are prime numbers only. So I'm going to think of a multiplication problem that will give me an answer of 48. So I'm going to go with 6 times 8 is 48. 6 is composite, 8 is composite. So I know I need to continue breaking down the branches of the tree. So I have 6. 2 times 3 is 6. 2 is prime, so I'm going to circle that. That lets me know I'm done with that branch. 3 is prime. I'm done with that branch. Now let's move over to 8. 8 is composite, so we need to continue to break that branch down. So 2 times 4. 2 is prime, I circle it. 4 is not, so I need to break the branch down some more. A multiplication problem that gives me an answer of 4 would be 2 times 2. 2's prime, 2's prime. Now you don't want to ever use on prime factorization like 1 times something because you're not going to get anywhere on your tree. You're just going to keep breaking down to the same numbers over and over again and you're never going to stop. So let's not use 1 times something on a factor tree. So all of my numbers 2, 3, 2, 2, and 2 are my prime numbers. All of my branches have ended, so I know I'm done with my factor tree. Now I need to convert these circled numbers into a multiplication problem that are prime numbers only, and they have to be in numerical order as well. So I have 1, 2, 3, 4 2's and 1 3. So my problem would be 2 times 2 times 2 times 2 times 3. Or we learned how to write exponents when we have like 2 times 2 times 2 times 2. Remember we did exponents a couple weeks ago where we did 2 times 2 times 2 times 2 can be written as 2 to the 4th power, because 2 is my base number, and I have 4 2's, so I'm going to write my exponent as 4 times 3. So I can either write it like this, or I can write it like this. Either way is acceptable. Let's look at example 2, 20. So I'm going to think of a problem. 2 times 10 is 20. 2 is prime. I circle it. 10 is not. It's composite. So I need to break it down again. 2 times 5. 2 and 5 are both prime. I have no more branches to break down, so I know I'm done. So my prime factorization are my prime numbers only. 2 times 2 times 5. Or 2 squared times 5. That's just writing it in exponential with exponents, exponential form there. Okay? Tomorrow we're going to look at the ladder method. So in class tomorrow we're going to do some problems with factor trees, practice those, and then on the next day we'll be working on the ladder method.